In this video, we will try to visualize how attention scores are calculated in an LLM training process. So the process requires multiple steps, and to make it intuitive and easier to learn what are the steps, I created this UI using Cloud AI and DeepSeek. So let's start using this one and let me show how it works. So for keeping this simple, there has been some simplifications that has been done, like the query key and value. These are three vectors for each of the words, and this is generally 768 dimension, but for simplicity, keeping it just 2 dimension each of these vectors. So first we will enter the tokens. So what are tokens? Actually, when we are training these LLMs, the entire paragraph or the data set that we have gets broken into token. They are token IDs are generated, then batch, when they are taken as input in batch. So for example, here we are taking as a batch of 4. So 4 input tokens we are taking at a time, and then our LLM will be predicting the fifth one. So that way it will be training itself by predicting the next token. In this UI, the training part is not implemented, it's just the attention scores calculation. So we'll take a look at that one only in this video. So for example, let's say my tokens are I like to eat. So as you can see, while I was typing, it was generating some token IDs, and this is done by an hashing process. You can see the function, this tokenize. This is doing some bitwise operator and generating a hash. So for a given word, we will always get a same token. For example, the like has 1751. So if I enter like here, I'll again get 1751 token ID. Change it back to eat. So these are the token IDs. Next is these three vectors for each of the tokens, query key and value. There is one more embedding vector also. So I did not ask it to do that one. So maybe that is one more simplification that has been done. Maybe in future videos, if I get a chance, I will add that also. So for now, let's say these are the three vectors for these query key and value, for this one, for this one, for this one, and these vectors are initially generated by several strategies. Maybe it can be done with random values initially, because during the training these gets fine-tuned based on the errors. But in this implementation, what I'm seeing how it did was, it is taking a seed value, that is the token ID, and using that seed value, it is doing some mathematical operations like sign and multiplication, and that way it is generating. So that way, actually what happens, it will always be, the vector will also be always same instead of random. That is the initial value, but anyway, even if we do it with random also, it gets fine-tuned in the training process. But in this case, since it is not using random, it will always be same for a single same token. So if I remove this I and type I again, I will get the same value. If I give it a like, I can see these vectors are matching these. Okay, so coming back, I make it back I. So this is the first part, getting generating the token ID, then generating the query key and value vector. It's kept 2 dimensional, all these vectors for simplicity. Next is doing a dot product between the q and k. So these are the values again printed, whatever was there in the top, same things are here. So this is a n by n matrix, where n is the size of the number of tokens in our batch. So that is 4 by 4. So for each of the tokens, their query and key is done a dot product between the two, and this table is generated that way. Next is using the third vector, the value. Wait, before that, there is one more process, this softmax. So this multiplication of this dot product can lead to some arbitrary large or negative values. So for that, there is a normalization being done, and that normalization is done using a softmax function. The implementation you can see in this code, this is a standard implementation of softmax. So what it does is, for each of these rows, you can add them up and it will be 1, score 1. So total it will be 1. If you add, let me take a calculator. So 0.294 plus 0.208 is 0.396 plus 0.102. So 1. So if you add, it is either 1 or 0.999, because sometimes I think I have seen based on my past tests. So due to maybe due to rounding off or something, it's sometimes getting 0.999. So that's the thing being done here at softmax to make them normalized. So the sum becomes 1. And finally the value vector, the third one is used. And here you can see the calculation is shown here also. It is these levels are generated dynamically based on what values we have in the above tables. So this one you can see the prefix with which it is multiplied. You can see this is coming from this table single row: 0.294, 0.208, 0.396 and 0.102, and this is being multiplied to each of the value vector of each of the tokens. So minus 2.07, minus 2.43, this is the value vector of first token. Similarly, minus 1.98, minus 1.58 is the value vector of the second token. This is the way it is done, and this is the final output that it generates: a new vector with the value minus 1.55 and 1.55. This one and this one. These vectors actually give similarity between different tokens, and that is similar vector is actually this matrix itself. How token 1 and token 3 are similar, and this gets fine tuned during the training. So initial value, whatever the token IDs were there and the vectors were there, this was directly dependent on token ID. So currently we don't have any context of our entire training data to fine tune these values. But once the training process starts, these similarity values and all those things are modified based on the errors that it got while predicting the next token. So suppose I like to eat and the next token was uh, mango. So if it did not predicted mango, whatever token it predicted, error is found out between the mango and that token, and then based on that error, all these values are modified to minimize that error, and that way the entire training process runs. So yeah, even at this point, even I'm also not having full clarity on the training process regarding the errors, but I have been working recently on RNN and these algorithms. In RNN, I have seen how the error is calculated. That is basically the square value of y actual minus the whatever is actual value minus the predicted value. It's a square, and that error is minimized by doing differential of each of the weight. That is, I'm talking about the RN, not this attention mechanism. So something similar is done for this as well. So once I get more clarity on that process, I will be extending this video and maybe updating this UI with more of that, so that we might be able to cover the entire training process in this UI. So that's it for this video.